Hello everyone and welcome. Today we are going to delve into a powerful algorithmic technique known as the two-pointers technique. The two-pointers technique is an efficient problem-solving approach that uses two references, often called pointers, to traverse a data structure in a coordinated manner. Let's get started. So, what exactly is the two-pointers technique? At its core, it's an algorithmic pattern where two references or pointers move through a data structure, typically an array or a linked list, to find a solution efficiently. The beauty of this technique lies in its ability to reduce time complexity. Instead of using nested loops, which can lead to a time complexity of big O of n squared, the two-pointers approach often achieves a linear time complexity of big O of n, making it much faster for large datasets. In the array shown here, we have two pointers. One pointer starts from the leftmost end and another from the rightmost end. Now the question arises, when should you employ the two-pointers technique? It's particularly useful in several scenarios. First, when working with sorted arrays, the two-pointers technique can efficiently find pairs or combinations of elements that satisfy certain conditions, such as finding two numbers that add up to a target value. Common examples include problems like 2-sum, 3-sum, or finding a pair with a given sum. Second, when dealing with palindromes, you can efficiently check if a string is a palindrome, or find palindromic substrings, by comparing characters from both ends of the string. Examples of such problems include valid palindrome and longest palindromic substring. Third, for sliding window problems, where you need to find subarrays or substrings that meet specific criteria, the two-pointers technique provides an efficient way to maintain and traverse the window. Common examples include minimum size subarray sum and maximum subarray. Finally, partitioning problems where you need to rearrange array elements based on specific conditions, the two-pointers technique can help you achieve this in linear time. Examples of such problems include the Dutch national flag problem, sort colors, and remove duplicates. Now let's explore some common patterns within the two-pointers technique. One common pattern is the opposite direction approach. In this approach, you start with two pointers at opposite ends of the data structure and move them towards each other until they meet or a specific condition is satisfied. This pattern is often used when working with sorted arrays or palindromes, as we discussed earlier. Another common pattern is the same direction approach. In this approach, both pointers move in the same direction, but at different speeds or under different conditions. This pattern is particularly useful for detecting cycles in linked lists or finding specific elements within a data structure. One pointer is called slow and another is called fast. Let's solidify our understanding with a classic example, the 2-sum problem. The problem statement is, given a sorted array of integers and a target sum, find two numbers in the array that add up to the target. For example, if our input array is 1, 3, 4, 5, 7, and 9, and our target sum is 8, the output should be the pair 1 and 7, which are located at indices 0 and 4, respectively. A naive approach to solving this problem is to use nested loops to check every possible pair of numbers in the array. However, this approach has a time complexity of big O of n squared, which can be inefficient for large arrays. A more efficient approach is to use the two-pointers technique. By initializing pointers at the beginning and end of the array, and moving them based on the sum comparison with the target, we can achieve a time complexity of big O of n, significantly improving performance. Here's how we can implement the two-sum problem using the two-pointers technique in Python. First, we define a function called to_sum that takes two arguments: nums, which represents the sorted array of integers, and target, which represents the target sum. Inside the function, we initialize two pointers: left, which starts at the beginning of the array, and right, which starts at the end of the array. Then we enter a while loop that continues as long as the left pointer is less than the right pointer. Inside the loop, we calculate the current sum by adding the values at the left and right pointers. If the current sum is equal to the target, we found our pair, and we return it as a list containing the two numbers. If the current sum is less than the target, we need to increase the sum, so we move the left pointer one step to the right. Otherwise, if the current sum is greater than the target, we need to decrease the sum, so we move the right pointer one step to the left. If we exit the loop without finding a pair, it means there is no solution, so we return none. Let's consider another example, the palindrome check problem. The problem statement is, determine if a string is a palindrome, that is, reads the same forwards and backwards, considering only alphanumeric characters and ignoring case. For instance, the string racecar is a palindrome while the string hello is not. To solve this problem using the two pointers technique, we initialize a left pointer at the beginning of the string and a right pointer at the end of the string. Then we compare the characters at the left and right pointers, moving inward while skipping any non-alphanumeric characters. If we encounter any mismatch, we return false, indicating that the string is not a palindrome. Otherwise, if we reach the middle of the string without finding any mismatches, we return true, indicating that the string is a palindrome. In the illustration shown here, we have a palindrome racecar with left and right pointers, one at each end. Here's the code implementation for palindrome check using the two pointers technique. First, we define a function called _palindrome that takes a string s as input. Inside the function, we convert the string to lowercase and keep only the alphanumeric characters. This ensures that we're comparing characters regardless of case or non-alphanumeric symbols. Next, we initialize two pointers, left at the beginning of the string and right at the end of the string. Then we enter a while loop that continues as long as the left pointer is less than the right pointer. Inside the loop, we compare the characters at the left and right pointers. If they're not equal, it means the string is not a palindrome, so we return false. Otherwise, we move the left pointer one step to the right and the right pointer one step to the left, continuing the comparison. Finally, if we exit the loop without finding any mismatches, it means the string is a palindrome, so we return true. Now let's discuss a variation of the two pointers technique, known as fast and slow pointers. In this variation, both pointers move in the same direction but at different speeds, typically with one pointer, the fast pointer, moving twice as fast as the other, the slow pointer. This technique is particularly useful for detecting cycles in linked lists, finding middle elements, finding the nth element from the end, and determining if a number is a happy number. The node with value 2 is a slow pointer while the node with value 4 is a fast pointer. Before we conclude, let's discuss some best practices to keep in mind when using the two pointers technique. Always consider boundary conditions, such as empty arrays or strings. Check for empty input data structures to avoid unexpected errors. Validate if the two pointers technique is indeed applicable to the problem. Sometimes other techniques may be more appropriate. Consider sorting the data when it benefits the algorithm. Sorting can enable the use of the two pointers technique in certain scenarios. Test your solution with various test cases to ensure it works correctly under different conditions. In summary, the two pointers technique reduces time complexity, works efficiently on sorted arrays, is great for palindrome and cycle detection, helps avoid nested loops, and has multiple variations for different scenarios. Thank you. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.